This is the sixth of the videos on a theory for gravity, and I'd like to go over once again the analysis of the energy shell. Remember that I said that when the moon left the Earth, it went to the surface of an imaginary energy shell that is twice the distance from the Earth. The radius is twice that of the current orbit of the moon, and that it circled the Earth in what was to our vision a straight up and down elliptical orbit, because we can't see the energy shell, so the orbit was straight up and down, a highly eccentric elliptical orbit. But that this evolved over a period of 4.5 billion years to a circular orbit that is as you see, half the radius, the initial radius, but it's still on the surface of the energy shell, so that the energy of the moon relative to the Earth has remained constant. Now I'm going to just go over this and give you a little more detail about it. Here I have drawn a diagram of that shell, showing you how the energy is divided between being potential energy and kinetic energy. Now the Earth is at the center of this shell, and most of the potential energy is actually already accounted for at the surface of the Earth, it being nearer to the center of mass of the Earth than the moon has been at any time. So in the center of this diagram you have the Earth, but the energy distribution is extremely nonlinear. Of the initial energy that the moon had, that being the potential energy at the Earth's surface plus its kinetic energy, took it to the surface of the shell. And at that time, with the vertical eccentric elliptical orbit, the energy was entirely kinetic, or almost entirely kinetic, when it was near the Earth, and when it was far from the Earth it was almost entirely potential energy. But after it had become a circular orbit, which is shown here on the surface of the shell, it has half the radius, and RC there is the radius of the orbit of the moon as it is now, half the initial radius. But as you see, the amount of potential energy as shown by this half of the radius is in fact almost the entire amount of the energy of the moon, and what's left, the kinetic energy at the top, is in fact only a very small amount of energy, because the force of gravity being so much greater near the center of the Earth, the amount of kinetic energy added in the outer half of the circle is extremely small. The order of 1% of the moon's energy is in kinetic energy. It's now traveling at only a few thousand miles an hour, compared with its initial 24,900 miles an hour. Now, the equations for this are that the kinetic energy, as you see at the top here, the kinetic energy of the moon now is half mv squared. I'm not allowing for the relativistic increase in mass. That's very small, but it doesn't affect the theory. The kinetic energy of the moon now is half mv squared, where vc is the circular or the orbit velocity, and this is compared with the potential energy, which is equal to the change in kinetic energy between the moon's initial velocity of v0 and its current velocity of vc, you see that the potential energy of the moon relative to the Earth is half m times the difference between the squares of those two velocities. And this is also equal to the mass of the Earth times the mass of the moon times the universal gravity constant times the ratio of the reciprocals of the two radiuses. Now these energies, by the way, the kinetic energy and the potential energy, are all in addition to the Earth's potential energy. You've got to add that in, and that is in fact larger than any of the other energies, because the Earth's surface is much nearer to the Earth's center of mass than the moon has ever been. Or it was the same as what it was when the moon was initially. So these numbers show us how the energy has been redistributed from initially kinetic energy into mostly potential energy, and that's where we stand right now. And the next, well, this has been the 6th program. The 7th one will be perhaps even more interesting when I talk about the additional information regarding the theory of gravity. Thank you very much for watching this video.